Hello dear friends, welcome back to my YouTube channel Chemistry Aspirant. Now in today's lecture, we are going to know about the rules for writing the formula of the complex compound or coordination compound when the IUPAC name is given. So in the previous lecture, we have learned about the rules for writing the IUPAC name for the coordination compound when the formula were given. Now here we are doing exactly opposite thing. We are writing the formula of the coordination compound when the IUPAC name of that complex compound is given. So let us discuss which are the important rules which we must consider while writing the formula for these coordination names. So now let us discuss about the first rule. While writing the formula of the complex compound or coordination compound, the symbol of the central metal ion is written first, then anionic ligand, then cationic or the neutral ligands. Let us consider the example regarding this one. So now here you can observe that the IUPAC name is given as an pentaamine carbonato cobalt oxidation state 3 chloride. We know that generally the name of the negative ligands end with the suffix O, so you can easily identify the negative ligand here. Your carbonato, then the neutral ligand is a pentaamine. Here we already learn about this rule 1. We have to write the symbol of the central metal atom or ion. Cobalt is here your central metal atom or ion and its symbol is CO. Then the anionic ligand is a carbonate. So obviously it is having the formula CO3 2 minus as it is in the negative form 1. Then neutral ligand is your amine and its formula is NH3. So while constructing this formula for this complex compound, we already studied the rule. That is, we know that we have to first of all write down the symbol of the central metal ion. Hence in the coordination sphere I have written the symbol of central metal ion, that is cobalt first. Then it is followed by your carbonate ligand 1, that is your CO3 ligand. Okay, no need to write the charges here, just I want to clear that it is a negative ligand. Then we know that it is a pentaamine, but amine is a neutral ligand. Hence I will write NH3 5 times in the square bracket, and we know that we have written the oxidation state and then we have written the chloride. Then I will just calculate the oxidation state. We know that carbonate is having the -2 charge, so therefore it will be the -2, and the Cl is in the form of a chloride ion, that will be having the oxidation number, or it will have the charge -1. So -1 and -2, that will be the +3. So oxidation number is here +3, and hence we can easily construct simply the formula for this coordination compound here. Now let us discuss the second rule. If there is the 2 or more different types of the anionic or the cationic ligands, then they are written by following the alphabetical order by the first symbol of their formula and not on the basis of the name of that ligands. Now let us discuss the example regarding this one. I have taken the IUPAC name as a triamine bromo chloro iodo cobalt oxidation state 3. Here you can observe that the central metal atom or ion is a cobalt and its symbol is a CO. Then the negative ligands are actually the bromo, chloro and iodo. So that is in the form of a bromide ion, chloride ion and the iodide ion. And if we consider simply their atomic symbol, we know that bromine is represented by Br, chlorine by Cl and iodine by I. So alphabetical order will be, we know that alphabetically B come first, then C, then I. And you know that there is only one neutral ligand, actually that is amine 1. So your neutral ligand is amine and its formula is NH3. So while writing the formula of this coordination compound, we know that we generally write the central metal ion first, then followed by the negative ligands, but here there is a 3 different negative ligands one, such as bromine, chlorine and iodine. So here I have considered the first alphabet of this bromine, then the chlorine, we know that here it is a C1, B, after B there is a C, then I, is it right? So I have written the sequence of this ligand as an Br, Cl, I, and the lastly the triamines, hence NH3, and then all these entities are closed in the square bracket. So this is the formula of your complex compound, and this is about your rule number 2nd. Now before discussing the rule number 3rd, you have to note one important point, and that point is regarding the complicated names of ligands one. Generally for the complicated ligands, the abbreviations are used. So here I have shown this table in which I have written its name, then their formula, the original formula, and then their abbreviations. So here you can observe that when the molecule is your ethylene diamine, you need not to write this whole formula there. Simply you will write the abbreviated form, that is EN, for your ethylene diamine. Then the next example is your pyridine. So here your simple abbreviation form is a PY. The next, that is your acetyl acetonato, and its abbreviated form is a ACAC. Here you can observe I have again given one example. I have actually written the formula again. So now let us discuss about the rule number 3rd. Complex ligands are accepted in abbreviated name in a parenthesis. But remember that while writing the formula for this complex ligand, the first symbol of their formula is considered and not the first letter of their common names. Let us consider the example regarding this one. I have taken the example, that is aqua, bis, ethylene diamine, pyridine, nickel, oxidation state +3 ion, is it right? So obviously you can observe that the central metal atom or ion is a nickel here. Then there is a one simple ligand, that is your aqua. We know that aqua is a water molecule. Then there is a 2 complex ligand, that is your ethylene diamine and the pyridine. We know that the ethylene diamine can be written in the abbreviated form as an EN, and pyridine can be written in the abbreviated form as an PY. Is it right? So definitely whenever, now actually in this example all ligands are the neutral ligands one, then we have to follow the alphabetical order. Definitely whether it is a simple or the complex ligand, it doesn't matter. We are simply going to follow the alphabetical order on the basis of the first letter of that formula one. So here I have written the formula for this complex compound as a symbol of the central metal ion first. Then your bis ethylene. So here ethylene diamine is written in the abbreviated form as an EN 2 times, but alphabetically E come first. Then we know that aqua, that is your water, and E. After the E there is a H, and then pyridine, that is PY, and the whole oxidation number is a +3, so it is a ion one, hence I have written the +3 charge as a superscript here. Writing this complex ligand, we just follow the first letter of their formula. Alphabetical order is not followed on the basis of their common names such as ethylene diamine or the pyridine one. So this is about your rule number 3. The rule number 4. There should be no any space between the anionic, cationic or the neutral spaces while writing the formula. Let us consider the example regarding this one. Let us discuss the example, that is tetramine, aqua, chloro, cobalt, oxidation +3 ion. So here the central metal atom is a cobalt and its atomic symbol is a CO. Then the neutral ligands are actually the aqua, that is your water molecule, and ammonia, that is your NH3 molecule. And negative ligand is actually the chloride ion, that is your chlorine one. So here I have written the formula as an CO without space, chlorine, then without space water molecule, then without space tetraamine, and the oxidation state will be +2. So here you can observe that chlorine will have the oxidation state -1, and this whole is having the 0 oxidation state, therefore -1. If it goes to your right hand side, it will become +3, so +3. Okay, so that's why I have to write the charge as a +2 here. So simply, whether it is a cationic, anionic or the neutral entity, we should not give any space in between them one while writing this formula. That is your rule number 4. Rule number 5th. The complete formula of the coordination compounds are generally enclosed in the square bracket. The oxidation state of the central metal atom or ion is written as a superscript if necessary in a Roman numeral. Let us consider the example regarding this one. That is your diamine tetrakis isothiocyanatochromate, oxidation state +3. So here the central metal atom is a chromium, then the negative ligand is your isothiocyanate ligand, which is having a -1 charge, then neutral ligand is your ammonia. Hence the formula of this compound is written as we know that we write the symbol of the central metal ion first, and I have written the oxidation state as a superscript to your central metal atom or ion, then followed by the negative ligand, as it is a tetrakis one, it is 4 times, therefore NCS 4 times, then ammonia, that is your NH3 2 times, and the charge will be -1. Okay, so you know that here I have written oxidation state, and this is the charge on this complex ion. So you can easily calculate the charge. We know that oxidation number we have taken for chromium as a +3. We know that there is a 4 thiocyanate ion. Now each thiocyanate having the charge -1, and ammonia is a neutral ligand, that is 2 into 0, which is equals to, suppose charge is x, we don't know the charge here. Okay, that's it. So you can do the simple mathematical calculations. You know that is 3 minus 4, the whole term will be 0, equals to x, therefore x will be equals to -1. So here I have written the charge as a -1 for this example. Now the rule number 6, that is our last rule. Overall charges on the coordination species is written outside the square bracket as a superscript while writing the formula of these coordination compounds. Let us consider a simple example regarding this one. So here you can observe that I have taken the 2 simple example, that is sulfato pentaamine cobalt, oxidation state 3 for your central metal atom, and it is ion one. Remember, so here I have written this formula for this coordination compound as an CO, as it is a central metal atom. So CO SO4, there is only one SO4, only one sulfato group is given, but it is a pentamine, hence NH3 5 times, and the charge is written as a superscript outside this square bracket, that is outside your coordination sphere. Those who do not understand, always remember that oxidation state is given. So oxidation state for cobalt is a +3 plus sulfate. We know that this sulfate is in the form of a SO4 2 minus ion, hence its oxidation number will be the -2, as it is a 1 time, hence into 1, plus we know that ammonia, it is a neutral ligand, hence its oxidation state is a 0, and it is 5 time, which is equals to x, because we have to calculate this charge one. So I am going to consider this charge as an x quantity. Okay, definitely we'll check out whether this charge is +1 or -1 simply by writing this mathematical equation one. So again do the simple mathematical calculation, 3 plus -2 into 1, that will be -2, therefore 3 minus 2, and 0 into 5, the whole term will be the 0, will be equals to x, therefore x will be equals to 3 minus 2 will be equals to +1. So this is +1 and +1. So again you can observe that in the second example, that is your tetranitrito borate, oxidation state for your boron is given +3 ion, and I have written the formula for this coordination compound as an BONO2 4 times, as it is a nitrito O, and the charge on this complex ion as an -1. Just calculate this charge. Again we know that oxidation state for the boron is a +3, hence the charge on the boron will be +3, plus there is a 4 nitrito group and each nitrito group will have the charge -1. We already discussed regarding this one, and I have to calculate charge, therefore I have considered it as an x. So you can simply observe that 3 minus 4 will be equals to x, therefore x will be equals to -1. So I have written this charge as an -1. So this is about your rule number 6th, which is our last rule for writing these complexes compound. Thank you so much for watching this video. Hope you will like this video and you are able to understand how to write the formula for the coordination compound if the IUPAC name is given.